Children, since last few days, a very sensational discovery of NASA is taking round in the gallery of scientific world. NASA has discovered an asteroid which contains enough of gold to make even every citizen of Earth billionaire. And not only gold, it has been found to be loaded with the extremely precious metals like platinum, nickel, etc. Also, sounds dreamy, isn't it? Children, bringing chemical formula for you today, and then you will ask that I expect that you will get off a little much that I have not taken some topics which are coming between atomic mass, because which was my last lecture program, and I have jumped on chemical formula. So no, it's not right to blame me, because I have given you enough idea about the topics like what are the forms of the elements. I have told you what is atomicity, what are the ions, and what are molecules of elements and compounds. So after gaining that much knowledge, I think that you are in the right stage where you can gain the knowledge of the chemical formula. So why to delay and why not start? So what is chemical formula, children? Let me start telling you this, and that the chemical formula is the representation or presenting the correct information about the elements, the number of elements, the kind of elements, the number of atoms of each elements, the type of compound, etc., hidden in just one representation, and that is not the PowerPoint representation, that is the chemical formula representation. Yes, so chemical formula has high significance in the world of chemistry. High significance, I am saying, because this is the, you can say, the language of chemistry, and without language of chemistry, chemistry is just half done. No, not done. Chemistry is not done without the language of chemistry, which has just a specific language. So chemical formula is a very scientific language, very coded language. We will learn how to write the chemical formula. Every compound or element has a symbol. Every element has a symbol, and that symbol will be used in writing the formula. That symbol has its importance as a to represent the atom in free state also, but it is maximum use in writing the formula of the substance or compound or molecule, etc. So it is a very short way to represent and fast way to represent a chemical compound, and just by writing few alphabets and digits and some signs like dots, like plus and minus, some brackets, etc., we get a right formula, we achieve a right formula of a chemical compound. So this is your chemical formula, which is your representation to express the chemical compound. Now I am telling you that chemical formula is not a chemical name, that must I tell you. It is not a chemical name. When you are writing the chemical formula, you can speak it just by speaking its alphabet. Like if I am saying NaCl, this is the chemical formula. If I am saying sodium chloride, this is your chemical name. This is the basic difference. If I am saying H2O, then it is water. Then it is your what? Water. But H2O, hydrogen oxide, this is the chemical name, and the formula, if you have to speak, then if I am asking what is the formula of water, you will simply say H2O, and I will be getting my answer. That's the right way to say the chemical formula. Only speak the what is the symbol and what are the number of atoms of each symbol. So what is the simplest way to express any chemical substance? That is to write its chemical formula. I am saying that it is a very rapid way to represent. And then, children, chemical formula, according to the law of constant proportion, expresses the empirical formula. What is the empirical formula? Empirical formula means that every substance is forming in its smallest proportion. The smallest proportion, like I have given you an example of a molecule, that is your glucose, and that glucose has its empirical formula CH2O. But what is its actual formula? Its actual formula is C6H12O6. So naturally we are just taking its smallest ratio, that will be what? Divided by 6. So CH2O, and that will be the empirical formula. So empirical formula will be applied mostly in the organic compounds, not in the inorganic compounds, because in the the organic compounds are bulkier in their structural formula. Structural formula means where we represent the formula in an open way with the bonds. Bonds are either covalent bond or dative bond or coordinate bond, etc. So empirical formula is the simplest way, or it is in the smallest ratio form. So what not a chemical formula can tell us about the chemical compound? What not I am saying, what it can do, that I am telling you that it can do, it can tell us many things, but what it can't tell, like it cannot tell us exactly about it. It is not as informative as the structural formula, where you will see that how the atoms are arranged, and how they are bonded. So that will be a lengthier way to write the formula of a substance by writing its structure. But since the chemical formula is a single line representation of chemical elements, so here we do not get the right information about the structure of the atom. For that you will have to know about the structural formula. Just by knowing the chemical formula we cannot understand that what are the bonds, how the atoms are arranged inside the chemical compound. Like chemical formula, just by writing a chemical formula we may not get the right information about the compound. That is also right. Like I am telling you an example of glucose. Glucose has its molecular formula as C6H12O6, but the C6H12O6 is the molecular formula of all the forms of sugar, like your all the forms of sugar, like your fructose, like your lactose, like your mannose. These are all the forms of sugar, and they all have the formula C6H12O6. But here what is the fact that it is actually the isomeric form. Isomers are what? Isomers are nothing but the same chemical formula but the different structural formula. So their structures are different. That is why the compound is the isomeric form of one another. Isomeric form of one another, like what are the isomers? These are the isomers: fructose, glucose, mannose, etc. The isomers which have the same chemical formula but different structural formula. So structural formula, what I mean to say that a final information and everything what we want to know, we can know about the compound by writing its structural formula. But chemical formula also is highly informative because it gives a very fast information. We can write the chemical formula in very short period of time. Really, after a long time, I am shifting towards my NCERT book. It was a big gap, but today in this class, I need NCERT badly, because in the NCERT, writing chemical formula is given in a best way. I will say that if you read the simply what are the different rules of writing chemical formula, you will become close to accuracy. So what is most important information you need to know about when you are starting when you start to write the chemical formula? It is valency, children. Valency, which is the combining capacity of any element. What is valency? Let me tell you first that the valency is the number of valence electrons. What are the valence electrons? You know that every atom has the different shells, and in different shells these shells are called energy levels, and in these energy levels electrons are arranged, and these shells are also called K, L, M. I will tell you individually a class will be taken on valency, but for today class also knowledge of valency becomes very important. Basic knowledge of valency I am telling you. So the valency is the valence electron, and valence electron are the outermost shell electron, and these electrons are also combining electrons. So in the case of metals, you will find that in the outermost shell either the valence electron will be in the number of 1, 2, 3, 2 or 3, या तो ये सबसे बाहरी शेल में 1 या 2 या 3 हो गए. जैसे कि मैं आपको बता रही हूँ कि एक केस लेते हैं कार्बन का. तो कार्बन में एक नॉन मेटल है, कार्बन की एटमिक नंबर 6 है और 6 एटमिक नंबर है कार्बन की. इसके 2 शेल होंगे K और L. तो K शेल में 2 इलेक्ट्रॉन होंगे और बच जाएंगे 4, तो वो चले जाएंगे L शेल में. तो वो जो L शेल के 4 इलेक्ट्रॉन्स है, दैट इज योर वैलेंस इलेक्ट्रॉन. अंडरस्टूड? एंड इफ आई एम टेकिंग द एग्जांपल ऑफ सपोज लिथियम, इट इज अ वेरी लाइट मेटल, lightest metal. So lithium has its atomic number 3. So naturally 1, 2 will be the arrangement of the electrons, means its electronic configuration will be in the shell K and L like 1, 2 and 1. So the one electron that is found in the L shell is your what? Valence electron. And that valence electron in the case of metals, I am telling you, metal के केस में तो जो वैलेंस इलेक्ट्रॉन होते हैं वही वैलेंसी होते हैं, क्योंकि मेटल के पास वैलेंस इलेक्ट्रॉन के नंबर जो होते हैं वो या तो 1 होगी या 2 होगी या 3 होगी, जबकि नॉन मेटल्स के केस में वैलेंस इलेक्ट्रॉन के नंबर या तो 5 होंगे, 6 होंगे या 7 होंगे. तो नॉन मेटल के केस में वैलेंसी जो होगी दैट विल बी 8 minus either 5 or 6 or 7. We will subtract the valence electron from 8. Why 8? Because I keep telling you that the 8 is the octet number, and that is a magical number which is required to achieve the configuration of noble gases which are complete in their octet, and this is the reason that why they are so stable. So every metal or every non-metal wants to achieve stability, and in order to achieve stability they gain electron. Either in the case of non-metal they gain either 1 electron, 2 electron or 3 electron, or in the case of non-metal, in the case of metals, these extra 1, 2 और 3 इलेक्ट्रॉन फ्रॉम द प्रीवियस शेल, पहले वाले शेल से बाहर के शेल में 1 इलेक्ट्रॉन, 2 इलेक्ट्रॉन या 3 इलेक्ट्रॉन जो ज्यादा होती है वो अनस्टेबिलिटी देती है, तो उसको ये लूज करना चाहेगा. एवरी मेटल विल ट्राई टू लूज दोज इलेक्ट्रॉन्स विच आर एक्स्ट्रा देन ऑक्टेट, एंड बाय लूजिंग दोज इलेक्ट्रॉन दे बिकम they gain the structure of your noble gases. This is how the formation of this is how the attainment of stability is found in the case of metals and non-metals. So children, you find this table 3.6, a highly informative table where you will get the valencies of the ions, and these ions are very important in writing the chemical formula of the ionic compound. So these are the metallic ions, which is sodium, potassium, silver ion, and you can see the charges over the plus charge is given over the every metallic ions. These are all the metallic ions, and these charges either it is 2 plus or 3 plus or 1 plus, they are what? They are the valencies of that ions. Valency of the ion is nothing but a charge over it. And here you can see that these are the anions, and these anions have minus charge over it, and these minus charge are either 1 minus charge or 2 minus charge or 3 minus charge. So these charges, and these are the polyatomic ions. When the ion is formed by more than one atom and these atoms are bonded together and they behave like a single particle, like here I am taking an example of NO3 minus. तो NO3 minus में क्या है? नाइट्रोजन एक एटम है और 3 ऑक्सीजन एटम है, लेकिन यहाँ पे नाइट्रोजन और ऑक्सीजन एटम अलग अलग नहीं है, ये बॉन्डेड है. कोवैलेंट बॉन्ड होती है, कोवैलेंट बॉन्ड जो होती है वो सिर्फ नॉन मेटल्स में मिलती है, तो ये कोवैलेंट बॉन्ड से बॉन्डेड है. नेचुरली जब ये कोवैलेंट बॉन्ड से बॉन्डेड है तो ये एक बिल्कुल सिंगल मॉलिक्यूल की तरह बिहेव करेगी. इट विल बिहेव लाइक अ सिंगल मॉलिक्यूल एंड इट विल ऑलवेज स्टे टुगेदर, एंड द ओवरऑल चार्ज ओवर द आयन, दिस polyatomic ion, the polyatomic ions are also called radicals, children, because if they have plus charge over it, like you can see this is your NH4 plus. So NH4 plus is what? Positive radical, and this is your cation type of thing. Like here these are the cations and these are the anions, simple, and these are the positive radical and negative radical. Negative radicals are more, means the anions of the polyatomic ions are more in number, and this because the anions are bulkier. And one cation example also is given in the positive radical, that is your NH4 plus. ये जो NH4 plus है वो अमोनियम आयन है और ये पॉजिटिव रेडिकल है, बल्कि यहाँ पे और बाकी के जितने भी आप देख रहे हैं हाइड्रोक्साइड आयन, दिस इज नाइट्रेट आयन, दिस इज बाइकार्बोनेट आयन और हाइड्रोजन कार्बोनेट आयन, दिस इज कार्बोनेट आयन, दिस इज सल्फाइट आयन, दिस इज सल्फेट आयन, दिस इज फॉस्फेट आयन. These are all what? These are the negative radical or polyatomic anion also you can say, but it will be right to say radicals in the case of polyatomic ions. So these are the cations, these are the anions, and these are the polyatomic ions. This will come in great use when I will start telling you how to write the chemical formula. So get ready to learn that. So just turn the page of your NCERT book and you will find that the certain rules are given to write the chemical formula. I am not starting it with the first rule. I will start with the second rule. Why? I'll tell you soon. A compound consists of a metal and non-metal. The name of the symbol or symbol of the metal is written first. Yes. So first we will write if a compound is composing of metal and non-metal. If the compound is made up of metal and non-metal, then that type of compound is called what? Ionic compound. Because here there are two ions. One is a metallic ion and one is a non-metallic ion. Here one example of calcium oxide, sodium chloride, iron sulfide, copper oxide, etc. are given. Here what is metal? Calcium. What is non-metal? Oxygen. In sodium chloride, what is metal? Sodium. What is non-metal? Chlorine. In iron sulfide, and you can understand iron is the metal and sulfur is the non-metal. So these are the metals. So first we will write metal in while we are writing the chemical formula. पहले metal को लिखेंगे, उसके बाद आएगी non-metal. Non-metal will always come after the metal because metals are electropositive and non-metals are electronegative. So we first write metals and then we write non-metals, means cation first and then anion. Back to the first rule, that valency or charges on the ions must balance. Valencies or charges on the ion must balance means what? That we apply the valency crisscross, means the one metals valency will go on the non-metal and non-metals valency will come over the metal. In this way what will happen, there will be a neutralization of charge. Charge होगी, overall charge होगी, वो zero हो जाएगी. वो मैं भी आपको बता रही हूँ कैसे हो जाएगी, that you just keep patience. So the overall compound should not have any charge over it. And how it will become, it is a bit confusing, but I will clear your doubt soon. Then what is the third rule? That if the compound is made up of polyatomic ion, then we write the polyatomic ion if it is more than 1 in number. If the polyatomic ion is more than 1 in number, we keep it inside the bracket and then we write the number of the polyatomic ion outside the bracket. This is also very important rule. Like if the polyatomic ion is just 1 in number, like here an example of sodium hydroxide is given. Sodium hydroxide is a cation as sodium ion and the polyatomic ion is your hydroxide ion. Hydroxide ion is only 1 in number. That is why we are not writing it inside the bracket. No need to write one number in the bracket. One number is assumed that okay, it is 1. If it is more than 1, then you will need to write that number outside the bracket. Then I am telling you one more thing which is not given here, that to write the chemical compound, it is I have told you that the first metals are written and then non-metals are written. Then the metals will be pronounced how we will speak the metals and non-metals. Metals will be spoken just by its original name, like if it is copper, I will speak copper, and if it is oxygen, I will not speak oxygen, because that is not the correct way to speak the chemical formula. Cupric oxide I am saying, because the copper has 2 valency and copper also has 1 valency. If it is 1 valency, then it will be called as the suffix us will be added at the end of the metallic ion, and if it is the more valency, then ik will be the suffix that will be added with the metallic ion, and the non-metallic ion will be dragged. How it is dragged? Either by adding IDE means ide, or ATE means 8, or by ITE means it. These are the 3 ways we drag the anion part to speak it, to pronounce it. Like you can see that iron, I am speaking just iron, and sulfide, not the sulfur, sulfide, IDE is added. Oxide, just like that. I am giving you more than this example, much more example will be given. Now coming to that part of topic where you will actually learn how to write the formula of the compound. Here I have only given the rules to write the chemical formula, and now time has arrived that you will apply those rules. So very simple compounds we are starting with, like the compound which is your hydrogen chloride or hydrochloric acid, you say. Hydrogen chloride has 2 elements, hydrogen and chlorine, and both hydrogen and chlorine has single valency, 1 valency. So the valency here is writing hydrogen की नीचे 1 and chlorine के नीचे 1, and you can see that arrow is given that hydrogen's 1 valency is going over the chlorine, and the chlorine 1 valency is going over they are monovalent. Valency is also represented like mono, di, tri, tetra, hexa, etc., penta, hexa, etc. So they are monovalent, means 1 valency is there, so both of the valencies are going on each other and no need to write 1, so the final chemical formula will be only HCl. Now come to the second, hydrogen sulfide. Here the sulfur has 2 valency and the hydrogen has 1 valency. Naturally the valency of hydrogen will go over the sulfur, so there will not be any valency written here, and the valency of hydrogen is 1, so it is written with the sulfur S, and the sulfur's valency will be going towards the hydrogen atom, and that's why we are writing H2S. Likewise, some more compounds are given here, like here you can see that the carbon is always tetravalent, it has 4 valence electron, and chlorine is monovalent, so CCl4. Magnesium chloride, these are the simple compound. Now I am coming to some more examples which are given here, like in the case of aluminium and oxygen. Aluminium is tetravalent, it has 3 valence electrons, so Al2O3, means here both of the valency is applied on each other. No element has 1 valency, that is why we are writing the 2 valency of oxygen with aluminium and 3 valency of aluminium with oxygen. So crisscross of valency is looking very nicely here. This is the one of the good example, best example to understand the crisscross of the valency, because both of the elements valency is going over each other. Here you can see that calcium oxide. Now what will happen when the valency is equal in number? तब क्या होगा जब दोनों की valency same है, तो valency cancel out हो जाएगी. Like calcium is also divalent and oxygen is also divalent. No need to write Ca2O2, but you will simply write CaO because it will obey the law of constant proportion, that in the smallest ratio the compounds are formed. Try to see here that a polyatomic ion is used, which is the nitrate ion, and nitrate ion also is monovalent, and sodium ion is also monovalent. But I told you that if it is a polyatomic ion, then we sometimes need to keep it inside the bracket. लेकिन यहाँ bracket में रखने की जरूरत इसलिए नहीं है क्योंकि नाइट्रेट आयन पर एक ही वैलेंसी अप्लाई होगी, वो सोडियम की, और एक लिखने की जरूरत नहीं होती है, तो सिंपली NaNO3 which has the ion as sodium ion and polyatomic ion as the nitrate ion. Now come to the calcium hydroxide. You can also see that here we have applied the bracket rule. Why? Because the calcium has 2 valency and hydroxide ion has 1 valency, and then hydroxide ion will get the valency of calcium by crissing cross. तो crissing cross से क्या होगा कि calcium की valency जो है वो 2 hydroxide ion पे apply होगी, और that's why we have kept the hydroxide ion inside the bracket, and outside the bracket we are writing 2, and the final formula became what? CaOH whole 2. My very favorite compound, where you will understand how to write the compound of polyatomic ions. Like here, this is also a compound of polyatomic ion, but only the anion was polyatomic, the cation was just monoatomic. But what will happen if we have both cation and anion polyatomic ion, like ammonium ion, positive radical, and sulfate ion, negative radical, and positive radical ammonium ion is monovalent, and the negative radical sulfate ion is your divalent. So what is going on here? That we are keeping ammonium ion in the bracket because we have to apply the valency of sulfate ion over the ammonium ion, so we are keeping NH4 whole 2, which is the valency of sulfate ion, going over the ammonium ion, and sulfate ion will get the valency of ammonium ion, which is just 1, so no need to keep it inside the bracket. The final formula became what? NH4 whole twice SO4, ammonium sulfate is the compound. Now just look at some questions which are given after every topic. These blue color questions are really very, you can say, inquisitive questions which will make your concept clearer, of course. So the formula of sodium oxide, how you will write? Sodium has 1 valency, oxide ion has 2 valency, so how you will write? Na2O. Aluminium chloride, aluminium has 3 valency and chloride ion has 1 valency, so AlCl3, the 3 valency of aluminium will go over the chloride ion. Sodium sulfide, Na2S. Why? Because the sulfide ion has 2 valency and the sodium ion has 1 valency, which will be going over each other, so finally the compound's formula will be your Na2S. Magnesium hydroxide, hydroxide ion has just 1 valency and the magnesium is divalent, so MgOH whole twice, very common compound. And another pattern of question you can see here, that you have to tell the names of these compounds and the formula is given. I have told you initially in the start of the lecture that the chemical name is different and the formula is different. Name we speak differently, like Al2SO4 3. This I am speaking the formula, and but how the chemical name will be spoken? Aluminium sulfate. So you can also speak that dialuminium trisulfate. This is also a way to speak by representing the number of the cations and anion. Dialuminium because there are 2 atoms of aluminium, and trisulfate 3 atoms of sulfate ion. कैल्शियम डाइक्लोराइड, बट इसको कॉमनली हम लोग कैल्शियम क्लोराइड भी कहते हैं, लेकिन अगर ज्यादा एक्यूरेटली आपको कहना है तो कैल्शियम डाइक्लोराइड. डाई पोटेशियम सल्फेट, नो, बट simply just potassium sulfate because the sulfate ion has 2 valency, came over the potassium ion, and potassium ion's 1 valency is going over the sulfate ion. Potassium nitrate, calcium carbonate. This is how I conclude my today's class, children. I hope that you might have found it useful to understand the chemical formula, and in my coming class I will bring molecular mass and formula mass concept.